So we're going to take a look at section 1.4. I don't think there'll be anything in this section, unless we do a calculator type thing, that you haven't seen before. So this one is all about linear equations and inequalities. So the standard way that we write the equation of a line is y equals mx plus b. And does anybody remember what the m stands for in y equals mx plus b? Yeah, Ben?
M is the slope.
Yep, m is the slope. And b, what does that stand for? Yeah, Jeff.
B is the y-intercept.
B is the y-intercept. Yep. So m is the slope, b is the y-intercept. So anything that you can write in the form y equals mx plus b is what we call a linear function. Okay? Even if it's not written exactly in y equals mx plus b, but it can be rearranged so the y is by itself. That is the equation of a line. So what's important when we write something in y equals mx plus b? This is just basically telling us what m and b are. Does anybody remember what that capital R means? Yep.
It's all real numbers.
Yep. So this means m and b are elements of the real number system. So that means m and b are real numbers. And the only other condition on m is it can't be equal to 0, according to the definition of a function in our book, linear function. If m is 0, then you get what's called a constant function. Okay? That's a horizontal line. Okay, whether you still call a horizontal line a linear function, I think you could, but our book, that's how our book defines it. Okay. Any questions on that type of equation? Okay. So let's see if we can figure out how to write an equation for this situation. Okay, so there's a lot there. You really only need the numbers to make the equation. So it said 10 years ago, value of a house was 60,000. 10 years later, or now, it's 85,000. We're going to assume that there's been a linear relationship between the value of the house over time, which basically means the value of the house has just gone up like that. Okay, straight line. I want to find an equation to model that, and then I want to figure out when the house was worth exactly $71,250. So there's a number in this problem that is kind of like the y-intercept. Does anybody think they know what number up there would represent the y-intercept? Okay.
Would it be 60,000?
Yep. The y-intercept is always like a starting value or like an initial value. And the initial value of this house was 60,000. Okay, so that's our y-intercept. And the other thing we need to find is the slope. So I want to think of the information in this problem as like a coordinate. So let's say x value is going to be like years. Yeah, I just say years. And the y value is going to be the price of the house, measured in dollars. $60,000 was the value at the beginning, the very first value of this house. So how many years had gone by when the value of the house was 60,000? And if you think of it as your y-intercept, it kind of tells you how many years have gone by. Yep. None. So 0, 60,000. And what do you think my next coordinate in the table would be to represent the value of the house at 85,000? Like, what do you think the years would be? Yep. 10 years later. So 0, 60,000, there's your y-intercept. The other thing we need is the slope. So if you don't remember how to find slope, it's the change in y over change in x. y2 minus y1 over x2 minus x1. Okay, so we need to go back to our coordinates and calculate y2 minus y1. What is y2 minus y1 called? So in terms of the slope, it's the vertical distance between the points. But it's also called the rise. x2 minus x1 is the horizontal distance between the points. And we call that, okay, that's the run. Yeah. So slope is rise over run. All right, so let's find our slope. So what I would do is 85,000 minus 60,000 over 10 minus 0. So 85,000 minus 60,000, that leaves us with 25,000. And what's 25,000 divided by 10? Yeah. 2,500. So there's our slope. Okay, so slope, 2,500. Y-intercept, 60,000. Now let's write our equation. So Dex, what would be our equation using that information?
Y equals 2,500 x plus 60,000.
And in this problem, 60,000 is the initial value of the house. What does the 2,500 represent? I mean, I know it's the slope, but I mean in terms of the word problem. The 2,500 is,
the amount of money that house is increasing per year.
yes, exactly. It's a rate of change. It's the change in the value of the house per year, $2,500. Okay, so we found an equation. Now, when was the house worth $71,250? Where would we plug in that $71,250? Yeah, Lucas.
Y.
Yep, we're going to plug it in for y. All right, so we'll bring the 60,000 over to the other side. So 71,250 minus 60,000, and then divide that by 2,500. So 4.5 years after the initial value is when the house was worth $71,250. If I had a year, then I could, if I knew the starting value of that was the value in like 2020, then I could say, okay, well, halfway through 2024, it would be 4.5 years later, but we don't have a year or anything, so it's just 4.5 years after the initial value. Any question on that? Okay. So slope, there are two special cases for slope. Okay. This works most of the time, but there are two special cases, and this even works for one of the special cases. But if you had a horizontal line. What's the slope of a horizontal line? Jeff? 0. Yep. How about the slope of a vertical line? Undefined. Okay, so those are two special cases for slopes. They also have special ways the equations look. Okay, vertical and horizontal lines are not y equals mx plus b. They're missing a letter. Horizontal is missing a certain letter. Vertical is missing the other letter. Does anybody remember when you do the equation of a horizontal line, what's the letter that's by itself on the left? And usually you have a number on the right.
On the left, you have the y, and on the right, you have the x.
No. You're missing one of the letters when you write a horizontal line. It's just y. Y equals 2. That would be the equation of like a horizontal line. How about the equation of a vertical line? Yes, that would be x equals. Okay, horizontal lines we can graph on the calculator, vertical ones we cannot. Because the calculator, when it's in y equals mode, only graphs functions. And vertical lines are definitely not functions. All right. That's actually just summarizing what I just did on the other page. So this says find the equations of the horizontal and the vertical lines passing through the point 2, 3. So if you graph the point 2, 3, what would be the equation of the horizontal line that goes through the point 2, 3? Wait, yeah. Yep, y equals 3. And what would be the equation of the vertical line that goes through the point 2, 3? Yep, x equals 2. Okay, it's a little bit of a special case. It's not y equals mx plus b. But the special cases do come up. Okay. Any questions on that? All right, so earlier, Amanda, can you sign back in for me? Thank you. Yep, just scan your ID. So when you have something that doesn't have y by itself, it doesn't mean that it's not the equation of a line. If you can get y by itself, it could still be a linear function. So if I had this, what would be my first step to rearrange it so it's in y equals mx plus b? Where?
Minus 2x.
Yep, so we're going to minus 2x. And when we do that, you're not wrong if you write 6 minus 2x, but if you're really trying to get it in y equals mx plus b, you want to put that term with the x first. So we got negative 2x plus 6. And Holly, what would be my last step to get y by itself?
Divide both sides by 3.
Right. And when you divide an equation, you have to divide every term. Okay, so final answer is y equals negative 2/3 x. We don't usually change the slope to a decimal, just leave it as rise over run. So negative 2/3 x plus 2. So what's the advantage to taking it the way that I gave it to you and rewriting it in y equals mx plus b? What would this make easier to do now? Yeah. Yeah, it's a lot easier to graph it. It's not that you can't graph it in the other format, you can. But most people are more comfortable with it in y equals mx plus b. Okay, so you should be capable of rearranging an equation and getting a variable by itself. Questions on that? So y equals mx plus b is not the only way that you can write the equation of a line. Okay, another format is point slope. And if the information they give you in the problem is a point and a slope, it's a lot easier to use this formula because it's already set up to accept that information. Y equals mx plus b is not set up to accept a point and a slope. It's set up if you know the y-intercept and the slope. Okay, and if you don't have the y-intercept, this can be helpful. So let's try using that formula. Find the equation of a line that has a slope of a half, and it passes through the point -2, 3. Okay, what I would do first is let's just identify those 3 numbers and where they're going to get plugged in the equation up above. Lizzie, what's the 1/2 going to get plugged in for? Yep. So that's going to get plugged in for m. Aiden, what about the -2?
The -2 is going to be plugged in for the x.
Not the x. The x is gonna stay where it is. Think about, look at up above where it says suppose the point, and then it tells you the 2 variables that the coordinate is going to represent. Michael, can you help him out? What do you think the -2 is going to represent?
The x1.
x1. Yep. So that's going to be your x1. And Kaylee, what about the 3?
Your y1.
That's my y1. Yep. So you don't have to find the intercept at all. Even though it's not given to you, you don't need it. So let's fill everything in. Y minus y1 equals m times x minus x1. I changed it to a +2 because it's x minus minus 2. Okay. And that's fine. If they don't specify a format you need to leave your answer in, that is an acceptable format. That's point slope. What if they wanted y equals mx plus b? What would be your first step to change that? Yep.
Or distribute
Yeah, I would distribute the 1/2 first. So I would do that first. So y minus 3 equals 1/2 x plus 1. Now I would add the 3. Yeah. Okay, so they might ask you to take something like that and convert it into slope intercept. Any questions on that? Okay. One other format that we don't use as much, the book refers to it as the general form of an equation of a line. It's where you get everything on one side and you have 0 on the other. We get 0 on one side a lot when we're solving quadratics. But when we're dealing with linear equations, I don't usually set them equal to 0. Unless there's a specific thing I'm trying to do that requires that. But if I was just writing an answer for a linear equation, most of the time I would pick y equals mx plus b. So let's go back to the problem we just had, and let's see if we can write it in that format. Standard, general form. A lot of times when they write something in general form, they also don't have any fractions in it. So you might see the fractions cleared out. What could I multiply everything by in this equation if I wanted to get rid of anything that's a fraction? Yeah, get it?
2.
Yeah, if you multiply everything by 2, you'd have something like 2y equals x plus 8. And now if you put everything on one side, you could make it look just like general form. So you could have, like, let's say, x minus 2y plus 8 equals 0. Okay, I just minus the 2y to the other side. Okay, so that's something that would be considered general form. So on a test, if you had a problem like this, find the equation of a line with a slope and a point, and that was listed as one of the multiple choice answers, that is correct. It might take a little bit of work to figure that one out. Okay, you might have to get it in like point slope form first, and then convert it to that. But again, that's something you should be pretty comfortable with, just changing and rearranging things to get either a variable on one side by itself or maybe a number by itself. All right, so parallel and perpendicular lines. Okay, in terms of slope, how do parallel lines compare to each other? Yeah, Matt?
They have the same slope.
Parallel lines have the same slope, and they also have to have something that's different. Yeah? A different b, and b is the y-intercept. Yeah, because if they have the same slope, same intercept, then they're the same line. Yeah, so parallel lines, same slopes, different y-intercepts. How about perpendicular? This one's a little harder to remember. It has to do with the slopes. The slopes they're two things, actually. Yeah?
I don't know what to call it. I think it says R.
There is a word involved that starts with an R.
It's like negative is the
Negative reciprocal.
Yeah, the opposite reciprocal. So for example, if you had a line with a slope of 2/3, the opposite reciprocal is -3/2. You flip it and make it the opposite. So where you'd see a question involving parallel or perpendicular, I would give you maybe something like an equation of a line and a point, and I would say find something that's either parallel to this line going through this point or perpendicular to this line going through this point. Okay, so parallel means two lines have the same slope. If you want to find something parallel to that, what's the first thing you have to know about the thing I just put a red box around? Jack?
You have to know the slope.
You have to know the slope. So you've got to figure out the slope of 3x minus 2y equals 1, and what would be the easiest way to figure out the slope of that line?
Probably to subtract 3x from both sides and multiply both sides by -1. That or
Okay, so we could subtract 3x from both sides. I would agree with that. And then what did you say to do
and
next?
multiply each side by -1. So it's a positive one.
Well, if you did that, there's still one more thing you'd have to do after.
Divide each side by 2.
Yeah, so I would divide each side by -2, so we do both of those in one step. Yeah. So divide by -2. And that would mean, what's this, my slope that I'm trying to use to find something parallel to is what?
3 halves.
Yeah, 3/2. Okay, so now I know the slope I'm working with, 3/2. If they wanted me to do perpendicular in this problem, I'd be flipping that and making it the opposite. Okay, but it's not perpendicular. Okay, so we know the slope we're going to use is 3/2. And what else do they give me that I need to use to find the equation of the line? Yeah.
An X and Y.
They give me an x and a y value. They give me a 1 and a -2. X is 1. Y is -2. You have an x, you have a y, and you have an m. What format is perfect for plugging those 3 things in when you want to find the equation of a line? Yeah.
Slope intercept.
We need a b for that. Because slope intersect is y equals mx plus b. So we don't have a b. But we do have other information that would help us to use a different format other than slope intercept.
Would it be the one that you showed us where it was the y minus y equals m and then parentheses x minus x?
Yep. What's that called? Yep.
Point slope.
Point slope. So this information where you have an x, a y, and an m is exactly what I gave you right here. An x, a y, and an m. So you just do the same thing, except use the numbers we have now instead of those numbers. Okay, so any question on that idea? Finding an equation of something parallel or perpendicular? Like in Algebra 1, we'd go through like 2 or 3 examples of parallel and then 2 or 3 of perpendicular, but I'm hoping you guys are comfortable with that. Yeah.
How did you find the X and the Y values?
Those are given
Okay.
because it says the point has to pass through 1, -2. So they were given.
Okay.
Yep.
And for the answer, did you just leave it in point slope form?
Yeah, it didn't really say. It just said write an equation. Didn't say the format. So you could do y plus 2, y minus y1 equals m times x minus 1.
You wouldn't have to simplify or anything?
No, not unless it said to.
Okay.
The only way you'd have to is if it either said write your answer in a certain format, or if it was a multiple choice question and none of mine were point slope form. You may, like if all my answers were in the general form, then yes, you'd have to do this out, and that's when you get 0 on one side. You'd have to rearrange it. Okay, so last thing, inequalities. Graphing an inequality is really just like graphing a line. Okay, the easiest way to do it is y equals mx plus b. The only difference is where I just circled, you're not going to have an equal sign. It's going to be one of the 4 inequality symbols. Now, if you have a greater than or equal to or a less than or equal to, you have to draw your line a certain way. If you have a less than or a greater than, you draw it a different way. Does anybody know what kind of line you use if it has the equal to? Anybody remember?
Solid line.
Yep, solid line. If it doesn't have the equal to, you use, yep, man.
With a dotted line?
It's a dotted line. Yep, dash, dotted, same thing. After you figure out after you figure out what kind of line you need, then you have to figure out where to shade. Yeah.
Can I go back?
Yep, just sign out for me. Okay, so the way you can figure out where to shade, I can kind of simplify that a little bit. If you have a less than or less than or equal to, shade below. For greater than or equal to, shade above. Now, there's only one kind of line you could draw that shading above and shading below doesn't make sense. What kind of line could you draw on paper and there isn't really an above and a below? Yeah? Yeah. Okay, if you draw something vertical, there isn't really above and a below. So in that case, you shade in the direction that it's pointing. Okay? As long as you always set it up, letter, symbol, then number. In a special case, which is vertical, the direction that it's pointing will tell you which way to shade. Okay, but other than that special case, less thans are always shaded below, greater thans are always shaded above. Okay, and just to be clear about that, like if this is your line, this is above, that's below. All right, so let's try graphing this one with the shading, the line, whatever kind of line we need, everything. So 2x plus 3y is less than 4. Is this format the one that we said is the easiest format for graphing? No. So anybody tell me my first step to rearrange this so it's in a better format for graphing? Courtney? Yep, I'm going to move the x to the right side. Okay, I'm going to do it over here because I have more space. And can you tell me what would be on the right side once I do that? Perfect. Okay, it's better. It's still not quite what we want. What would be the last thing we would need to do? Yep.
Divide both sides by 3.
Divide by 3. Now, before I go any further, you have an inequality here. What do you have to be careful about when you divide when there's an inequality symbol in that problem? Yep, Leland?
Flip the sign.
If what? Because you don't always flip it.
If it's negative.
If you divide by a negative number, you need to flip the inequality sign. Yep. Divide or multiply. I did not divide by a negative number here. So y is less than negative 2/3 x plus 4/3. Okay. So I've rearranged my inequality in a slope-intercept type of format. It's not slope-intercept equation because there's no equal sign. Okay, it's an inequality. All right, now, how do I graph that? What's the first thing I do? Well, James, what's the first thing we do to graph that?
Mark the y-intercept.
Yep. So what it might be easier to think about it as a mixed number. What's 4/3? 1 1/3. Okay, so we're going to put our y-intercept at 1 1/3. Just kind of an estimate. And now, what's the next thing I do after I graph my y-intercept? Yeah.
The slope.
Slope.
Depends on the line, so left 2, down 3, or upward.
Yeah. So you could go. Well, you could go
down to. Right.
Yeah, I would go down to and right. How many? 3. So down 2 and right 3. Or you could go up 2 and left 3. You could go that way. But I would go down 2, 1, 2, and then right 3. 1, 2, 3. And there you go. You can do it one more time if you want. Down 2, right 3. Okay, so we've got three dots there, so we can kind of tell where our line's going to go. Now we have to decide if it's going to be a solid or dotted. What kind of line is this one going to be? Solid or dotted? Yep, Joe? Yep, dotted. How come?
Because it's not equal to.
Yep, not equal to. Okay, so that's close enough. So we got our dotted line. One more thing I have to do. When I'm graphing an inequality, what's the last step? Yep. Yep. And where are we going to shade this time? Shading above or below?
Below.
Yeah. How come?
It's
Right. It's a less than. Yep. So you shade everything that's under that line. And another way you can check if you did it right is pick a point that's somewhere in this shaded region. If you plug it in, it should work. Right? So a point to me that looks pretty easy and it's in the shaded region is 0, 0. If we plug in 0, 0, it should work in the original problem. 2 times 0 is 0. 3 times 0 is 0. 0 plus 0 is 0, and 0 is less than 4. So it works. If you pick a point and you plug it in and it doesn't work, then that means you shaded the wrong region. Like if you plugged in the point 2, 2, it's definitely in the other region. If you plug it in, you won't get an answer less than 4. Okay, so any questions on that? All right, so that's the section I was going to skip over, but I don't know, I figured it would be good to just review the y equals mx plus b stuff. All right. And since I pushed back one of the sections that we're not going to start this week, we got a little bit of extra time at the end of class today. All right, so you already did page 31. So the homework tonight is on page 42. I think it's like roughly 12 questions. So 2, 7, 8, 11, 16, 17, 20. And then 24, 27, 32, 44, and 77. All right, you've got probably the most time you'll ever have at the end of a class. You've got a little over 15 minutes. So please use the time to work on that and get started. If you need to catch up on homework that you missed, you can do that. And if anybody needs help with your Chromebook, now is a very good time for me to help you fix the calculator on your Chromebook.